Hello students, this is lesson 1.4.4. These are your notes for that lesson. So we are in our 4th week of this 6 weeks, the first grading period, and it is Thursday. So we're carrying on with triangles today. We're going to talk about special segments in triangles, and 3 of these special segments go from the vertex to the opposite side, and I think there's supposed to be a line right there. I'm going to draw a line to complete that triangle real quick. Not sure what happened to it. So there we go. Okay, so altitude, median, angle, bisector. All of these go from a vertex to the opposite side in some way. So all of them, we're going to take, a point, the vertex, that point, and we're going to draw a line from the vertex to the opposite side. Some of them it's going to be in the middle, some of them it'll be at a right angle, and so on and so forth. But these 3, altitude, median, and angle, bisector, they all go from a vertex to the other side. Perpendicular bisectors, different story, and we'll get to that after we talk about the other 3. Okay, so let's talk about the median first. All right, so a median is a line. It goes from the vertex to the midpoint. And we've talked about midpoint before of the, we'll say the opposite side. So if I were going to draw a median, I'm sorry, I was looking up here, a median from this vertex to the other side, it would go from the vertex to the midpoint. So that would be about halfway, and I'm just going to estimate about what halfway would be. So it would be a line segment from the vertex to that midpoint. Let me grab my line tool again, and we'll do red for this one. So I'm drawing a line segment from the vertex to the midpoint of the other side. Now, you can draw 3 of these. There are 3 medians in each triangle. The exception, no, there are 3 medians on each triangle. So let's do another one. Let's pick a different color. Let's go from this vertex to this midpoint over here. And so let me grab my line tool again and do blue. So from that vertex to this midpoint here. Now what should happen is when I draw the 3rd median, they all should meet at a point in the middle. Now, of course, I've estimated where my midpoints are. If I were to use a compass, or if I were to measure and get exactly where that midpoint is, then I would know that these 3 medians were going to meet at that point right there in the middle. I'm going to try my best. So let's see if I can estimate where this let's do green on this one. You know what I'm going to do, instead of that green, I'm going to do like a neon green because I think it'll show up better. So from this last vertex right here, and I don't know, let's see, maybe about there. Let's see what happens. See if we can get a line segment that will be pretty close. Alright, so that was a pretty good estimate. So these 3 meet in the middle. Now, in Math 3, we're going to talk about what this point is called. We'll talk about this segment versus this segment and the relationship that they have. We're not going to worry about that in Math 2, but I do want you to understand that each of these, you might see these tick marks, and you remember these mean that these 2 sides are congruent. Because this is the midpoint of this segment, this little segment is congruent to this little segment. And so over here on this side I would do the same thing, but I need to put 2 tick marks on each side just to show that this segment right here is not necessarily congruent to this one, but these two that are marked with the blue tick marks, those are congruent. And then let's go and mark these also, and what we would do is mark these with 3 each. So the ones with 1 tick mark are congruent, the ones with 2 are congruent, and the ones with 3 are congruent. So that's what a median is. It goes from the vertex to the midpoint of the opposite side. Okay, angle bisectors. They really don't have so much to do with the opposite side as they do with the angle. An angle bisector does this. Let's get a color here. An angle bisector. Now think about the word bisect. Bisect means cut in half, and it's talking about the angle. So an angle bisector cuts the angle into two congruent angles. We also draw those. We also draw the angle bisector to the other side, and those also meet in the middle. Now this is going to be a lot harder for me to draw because it's hard to know where this angle is cut in half. So from C, let's see, let's do a line. Let's say, I don't know, somewhere. That's really tough. Maybe about right there. So what we would do here is with our red pen, we would draw a little arc there with a tick mark and then another one there with a tick mark. And that would show that those two angles are congruent. They aren't. I can tell just by looking at them that I didn't do a very good job of getting it right, but close enough. Same thing with these though. If you draw the angle bisector from C, from B, and from A, they should meet at a point. It's not necessarily in the middle, but they should meet at a point. So I can I'll try to get, let's see. Let's do B in blue. So again, they're not going to be at the midpoint of the opposite side, but they do cut the angle in half. So then on this one, we would put, same thing, we put this, two tick marks, an arc, and two tick marks there. And then the last one, I don't think I can really get them to meet, but we'll see. Let's see, from A, I don't know. I'll just make it meet, and then we're just going to mark the angles. Okay, so then this one would have 3, and that's really hard to do. I can put it way out there. All right, so that's what that would look like. That's how we would show that these are angle bisectors, and they do meet in the middle. Or not in the middle, but they meet at a point. Okay, so the last type of segment that we're going to talk about that goes from a vertex to either, it doesn't necessarily go to the opposite side, and I'm going to show you in a minute why I say that. But what we'll say as far as an altitude does, it is a line from a vertex to the opposite side. And it is what we call perpendicular, and we'll talk about that word. I know you've seen it before. It is perpendicular to the side. And if you remember what perpendicular means, that means it meets at a right angle. You can paraphrase that however you want, whatever is going to help you. All right, so let's talk about what that would look like. And I'm just going to do one from each on each of these pictures because that's what it says. Sketch an altitude from vertex C to side AB in each triangle below. So let's get a line tool. Well, actually, let's mark vertex C. Vertex C is here, 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 and way down there. Okay. All right, so let's look at the first one. So if I go from vertex C over here, I need to make sure that it is at, that's not a right angle, that's not a right angle over there, so I need to get it as close as I can to a right angle. And then I'm going to mark that with my little corner like we always do for right angles. You can mark it on both sides or just one. If you do one, the other one's also a right angle. Now, this one right here is a little bit trickier because to go from C, let me get my line tool. To go from C to side AB, obviously none of this is a right angle. The altitude from C actually is out here. And it kind of stopped at the right angle. So what I do is I just kind of imagine that this side, I would just draw like a dotted line there. And then just mark my right angle right there. So that's actually the altitude on it. So if you have an obtuse triangle, one of the altitudes is going to be outside the triangle. Okay. A, if I went from A over here, then that would be on that side. B would actually be out here too, because I can't do a line segment from B over to AC. So actually, if you have an obtuse, then two of your altitudes are going to be outside the triangle, basically. All right, let's look at this one. This one already has an altitude because it's a right triangle. So on a right triangle, two of your altitudes are the actual sides themselves. So this is actually my altitude right here on this one. And then on this one down here, let me grab my line tool again. From C that one might be, I don't know, it's really hard to tell. This is an obtuse, so I think it's going to be somewhere out here. So there's my right angle there. So all the green lines, well, and that one, I'll do that one in green too. Let's do this. So all the green lines are altitudes. All right, so again, same thing though. If you do all your altitudes, they will meet at a point as well. So all of these segments that we were just talking about, they all meet at a point. And the points have names: centroid, orthocenter. You're going to learn those in Math 3. Don't worry about it. Okay, so the last one goes from a side. And I'm trying to think how I want to define this. I think I want to define a perpendicular bisector as, oh, it's not giving me my pen. Let me try again. A perpendicular, which we already talked about that. That means right angle. A perpendicular segment from the midpoint of a side. So this says sketch the perpendicular bisector of AB. So that is side AB. Let me mark side AB with blue. That side AB on this one and side AB on this one is right here. So the first thing I would need to do would be to find the midpoint of side AB. And I'm just going to estimate, because this says this side is congruent to this one, it's isosceles, this one actually will happen to go from the midpoint to vertex C. It's not always going to be that way. So this one would actually, well, I didn't do a very good job of estimating where the midpoint is, obviously, because it should go to vertex C. And then we're going to mark this, even though it doesn't look like a right angle, we're going to mark that a right angle. This one is going to look very different, though. If we estimate where the midpoint of AB is, somewhere like right there. Okay, so the perpendicular bisector for this one is going to go from that midpoint just up to there. It just has to make a right angle. So midpoint and right angle, perpendicular to the midpoint. Okay, so that's perpendicular bisector. So that's the only one that doesn't necessarily go from a vertex to the other side. It's got to go from that midpoint, and it's got to be perpendicular to the midpoint. So it's going to touch the side maybe over here somewhere, but it doesn't go from a vertex. So let's look at this chart and talk about what criteria each one of these meets. So let's think about the median. Think about what the median was again. It goes from the vertex to the opposite side, and it hits it at the midpoint. Let's draw the picture first. That might be easier. So if we just sketch a triangle like this, and we go from this vertex over to the other side to about the midpoint, and then we make those tick marks on this side. That's what it looks like. Okay, so it goes through the vertex, yes. It goes through the midpoint, yes. It forms a right angle, no, it doesn't form a right angle. It could, but it doesn't always form a right angle. Okay, altitude, let's talk about what that looks like. We'll draw maybe a triangle like this, and then we'll do from the vertex down, and it makes a right angle. So we'll draw a little right angle there. Okay, through the vertex, yes. Through the midpoint, no. It doesn't necessarily go to the midpoint of the opposite side. Forms a right angle, yes. Perpendicular bisector. Let's go down to angle bisector, because those are the ones that go through the vertex. Angle bisector, through the vertex, yes. Through the midpoint, no. It could, but it doesn't necessarily. And does it form a right angle? No. So angle bisector, let's do let's maybe do one like that. And then let's do a line segment from this vertex up here that maybe looks kind of like that. And then we'll draw an arc there and an arc there, showing that those two sides are congruent. So that's what an angle bisector looks like. We're not going to worry about this one. Perpendicular bisector, that's the one. Let's draw this triangle here. That goes from the midpoint of the side and is perpendicular to that side. So it doesn't, that's about right. Doesn't necessarily go to the vertex. It could, but it doesn't have to. Through the vertex, not always. Through the midpoint, yes. Forms a right angle, yes. Okay. So that'll kind of help us keep up with which one's which. So this next section says, sketch a picture of each statement. Segment AD is an altitude of angle ABC. I'm going to grab my triangle tool. Wait, that's not the one I wanted. This one. Okay, so I want to put A here, B here, and C here. And I want to go from vertex A. And an altitude, you remember, goes from the vertex to the opposite side, and it forms a right angle. So I want to name this point D, and I also want to mark that right angle. Okay, so that would be an altitude, and it's segment AD. Segment AD is a median of ABC. Let me see. What's that one look like? Oh, okay. All right, we can do that. All right, let's put A here, B here, and C here again. We're going to be going from A. A median, you remember, goes from the vertex to the midpoint. So let's kind of estimate where the midpoint of BC would be, somewhere about right there. And then we'll use our line tool and do that. And then this also needs to be called point D. This is segment AD in green. DE is a perpendicular bisector of triangle ABC. E is between B and C. Okay. So let's see. I want to do this perpendicular bisector. Let's do this one. This one always wants to be obtuse the other way, and I don't really want it to be that way, but that's okay, I guess. Okay, DE is a perpendicular bisector of ABC. Okay. So we'll do this again. A, B, C. We want to kind of keep it consistent. Perpendicular bisector. I need the midpoint of BC first. Let's see, that's going to be, I don't know, somewhere maybe right there. And then I need this to be perpendicular And my line tool is usually pretty good, but it's not. I'm bad at this. Okay, we can, as long as we make sure that we mark that, and then this would be DE. This is E right here, and this is D. Okay, so segment DE is a perpendicular bisector on ABC, and he said, and it said E is between B and C, so we did that right. So in the next section, it asks us to determine which special segment is shown for each. I want to skip number 1. I'm going to skip number 1 and come back to it. So I've marked over here median, altitude, perpendicular bisector, angle bisector. Let's look at number 2. Number 2, it looks like they've marked the 2 angles. So this is an angle bisector. So we'll just put A, B for that. Number 3, they've got these tick marks. There's the right angle, but it does not go from a vertex. So if it doesn't go from a vertex, we know that that's perpendicular bisector. Number 4, we have from a vertex to the midpoint. We know it's a midpoint because of these tick marks. This is congruent, these 2 segments right here. So that would be a median. Number 5, same thing, vertex to the opposite side, and these 2 are congruent, so that is also a median. Number 6 goes from the vertex to the opposite side at a right angle. It does not cut it in half though, so this would be an altitude. Number 7, it doesn't go to the vertex, so we know that that's perpendicular bisector. Number 8, it marks the angles, and so we know that that is an angle bisector. And number 9, this is an altitude because it goes from the vertex to the opposite side, and it's got the right angle mark, but these are not congruent, so it's an altitude. Now look at number 1. Number 1 goes from a vertex to the opposite side, and these 2 things are congruent, so I know it's a median. Also, it goes to the opposite side at a right angle, so I know it is an altitude. Yep. It's also a perpendicular bisector because this is the median and it goes up at a right angle. So it's a perpendicular bisector. I can tell you this, it's also an angle bisector. We don't have the rules for this, but this is something you do in Math 3. This is congruent, which means these 2 angles are congruent. So it's also an angle bisector. It's all 4 of those things in one. So number 1 is a little more tricky. Okay, let's look at the next section. I'm gonna pause this and we'll see if I want to do all these. I'm a little bit over time, so let me look at them. So maybe we'll do 1 from each section. RN is the perpendicular bisector of AT. In other words, this is the midpoint, which means this is congruent to this. So if we set these up equal to each other, we can find x. 10x minus 20 equals 5x plus 15. Let's subtract 5x over here, and then we'll add 20 over here. That equals 35. Divide by 5x equals 7. And that's what it asked us to find. Let's skip on over to, let's look at number 9. YB, which is right here, YB is the altitude of XYZ. So this is a right angle right here. YBZ is this angle right here, 6x minus 6. Okay, well, if this is a right angle, so is this. That means this equals 90 degrees. So 6x minus 6 equals 90. Let's add 6 over there, or yeah, add 6, 96, and I'm going to have to get my calculator. 96 divided by 6, that's 16. X equals 16. All right, let's move on. Let's look at number, is that a 2? These are, okay, these are numbered really weird. MR is the angle bisector of NMP. So 1 and 2 are congruent, is what they're saying. Find x if the measure of angle 1 is 5x plus 8, and if 2 is 8x minus 16. They're congruent to each other, so you set them up equal to each other and solve for x. I'm going to subtract 8x over here. That's going to be negative 3x. Subtract 8 over here. That'll be negative 24. Divide by negative 3. x equals 8. They only asked us to find x. They didn't ask us to find the measure of the angles. If they asked you to find the measure of one of the angles, then you would plug in the 8 up here. So 8 times 8 minus 16, and that would give you the measure of the angle. Let's see what else we've got. Oh, okay, we can do this one real quick. BD is a median. This is a median, so that means this is congruent to this, and they want you to find x. So 6x plus 3 equals 7x minus 1. Let's subtract 7x over here. That's going to be negative x equals, and then we're going to subtract 3 over here. That's negative 4. Just divide by negative 1. X equals 4. So on problems like this, a lot of times you're going to be setting them up equal to each other. Sometimes it'll be like this one over here, where you know that the angle sometimes you'll be setting them up equal to each other. Sometimes they'll equal 90, or you add something that's equal to 90. Sometimes you add and it's equal to 180. So those are usually the types of problems that you're going to see like this. All right, so I'm not going to do any more of these. We might hit on these when we do the classwork. If not, we'll just get as much of the classwork done as we can, and I will see you during the live lesson.